A simple linear regression model estimates the relationship between two variables. There is one independent variable which is denoted by x and one dependent variable which is denoted by y. The linear equation is y equal to mx plus b, where m is our slope and b is our intercept. There are four simple steps to create the simplest machine learning model. The first step is importing the necessary libraries. First of all, we import our required libraries. Here are two required libraries which are Matplotlib and Pandas. We have successfully imported both the libraries. The second step is importing the dataset. We will import the dataset on which we will create the model. This is the syntax to import a dataset. The dataset has been imported, and this is our simple dataset that I have created for the explanation purpose. Here are two variables. First one is experience, which is our x independent variable. The second one is salary, which is our y or dependent variable. We will estimate the salary depending on the experience of the employee. The third step is training the model, or you can say building the model. In this step, there are three lines of code which you have to learn. In first line, we will import the linear regression model from sklearn library. This is our first line of the code. In the second line of the code, we will create a linear regression object. This is the code to create a linear regression object. And in the third line of the code, we will fit our x and y in the linear regression model. This is our x variable, which is experience, and this is our y variable, which is salary. You have to remember one thing here, that we have to put x variable in the form of a 2D array. Means we have to write two brackets, while we have to use single bracket to fit the y variable. Now this line shows that the model has been trained or built successfully. In the fourth step, we will start making predictions. To predict, we will use the predict function. In the predict function, we will pass the value of x. If I pass 5, means 5 years, and if I see the result, it is showing that for 5 years of experience, the salary should be 31,484. We can check it from here. As you can see, it is showing the salary as 31,000, which is approximately close to our predicted value. You have to remember one thing here, that we have to put the x in the form of a 2D array. Means we have to put the value of x in two square brackets. If we predict one more value like 12 years, then you can see that it is showing the salary must be 70,896 for 12 years of experience. If we see here, it is showing that for 10 years of experience, the salary is 60,000. So we can say that the predicted value for 12 years of experience is approximately correct. So these are the four simple steps to create a simple linear regression models. If we want to see some more details about this model, then we can check these also. If we want to check the accuracy or the score of the model, we can use model.score, and it is showing the accuracy of our model is 99.6%, which is very good. We can also check the coefficient of our model with model.coef. The coefficient of our model is 5630, which is denoted by m. We can also check the intercept, which is 333.33, which is denoted by b. Now we can put these m and b and x in this equation and predict the y. To do so, first of all we will copy the value of m, which is this, multiply by value of x. If I use this value 5, means we are checking the value of y for 5 years of experience, plus b, which is our intercept. Then it is showing 31484, which is this value. So our model is very good. We can also draw the best fit line. The best fit line is drawn with the available data points and the predicted data points. This is the code to draw the best fit line. The red stars are the actual data points, while this line is drawn with the actual year of experience and the predicted salary. So it was about simple linear regression model. Multiple linear regression model. A multiple linear regression model estimates the relationship between two or more independent variables and one dependent variable, which is also called our target variable. Here, the dependent variable is denoted by y, while the independent variables are denoted by x1, x2, x3, and so on. This model describes how the value of dependent variable changes with the change in the values of the independent variables. The equation of multiple linear regression model is this: y equal to m1 x1 plus m2 x2 plus m3 x3 and so on. There may be many independent variables, and in the last we have the intercept, which is denoted by b. Here y is our dependent variable, while m are our slopes, m1, m2, m3 are our slopes, or you can say coefficients, and x1, x2, x3 are our independent variables. Now if we try to understand multiple linear regression model with an example, then in this figure there are three variables. First one is MPG, second is weight, and third is horsepower. The MPG variable is our dependent variable, which is y, while the variable weight and variable horsepower are our independent variables, which is x1 and x2. There may be any number of independent variables, say 5 or 10. In this example, we are trying to predict the value of MPG with the change in the value of weight and with the change in value of horsepower. Suppose if we keep the value of weight as 3500 and we keep the value of horsepower as 200, then what will be the value of our MPG? So this is the example of multiple linear regression model, where we try to determine the relationship between a dependent variable y and two or more independent variable x1, x2, x3 and so on. If we see what is the difference between simple linear regression and multiple linear regression, then in simple linear regression there is a single predictor which is denoted by x, and there is a single dependent variable or target variable which is denoted by y. While in multiple linear regression there are multiple predictors, or you can say independent variables, which are denoted by x1, x2, x3 and so on, and here also there is a single dependent or target variable which is denoted by y. So this is the simple main difference between linear regression and multiple linear regression. Now to build a multiple linear regression model, we have to follow simple 4 steps. The step 1 is importing necessary libraries. In this model example, we will use only pandas library. So I will import pandas as pd. This is the syntax to import the pandas library. The library has been successfully imported. The second step is importing the dataset. The dataset I have created is random dataset for the explanation purpose and to make this understanding easy. This is the path of my dataset. If I have a look at my data, then this is my dataset which contains only 23 rows, means it is a sample dataset for your understanding only. In this data, we have 4 variables: transportation, stationery, packaging are my independent variables, which is my x1, x2 and x3, while this fourth variable revenue is my dependent variable, which is y, as I have defined here. X variables are transportation, stationery and packaging, while y variables is revenue. We will use the head command to show only top 5 rows of this dataset. In this example, we will try to find out the revenue with the change in the value of transportation, stationery or packaging. The third step is training the model. To train a model or to build a model, there are 3 syntax. The first one is from sklearn library, we will import the linear regression model. And this is the syntax to import linear regression model from sklearn library. From sklearn.linear model import linear regression. If I run this, the command is being executed and the command has been executed successfully. The second step is creating a linear regression object. To do this, we will write model equal to linear regression. This is the syntax to create a linear regression object. If I run this, then the command has been successfully executed. The next syntax is fitting the x and y in the model. As I defined here that transportation, stationery and packaging are my x1, x2 and x3, while revenue is my y variable. So I will fit these 4 variables in my model. This is the syntax to fit x and y. We have to write model, which is my linear regression object that I have created here, and we will use the fit command. In the x, we have to enter these 3 first columns. So to enter these 3 first columns, the syntax is our data frame name, and x here needs to be in the form of a 2D array, means there will be 2 square brackets here. So we will put these 3 variables in these square brackets. This is my x here, and to put my y, I have to write my data frame name and my y variable name, which is revenue. So this is my x variables and this is y that I have fitted in the model. If I run this, then the command has been successfully executed and a linear regression model has been created. Now the fourth step is start making the predictions. We will make 2 predictions here, and to make the prediction we will use model.predict command. The syntax is model.predict. We will put a value of x1, x2 and x3 in the form of 2D array, means in double square brackets. So if I predict values for, let's say, my transportation cost 4200, second will be my x2, which is stationery if I write stationery as 1000, x3 will be my packaging. If I put packaging as 2500, then if I run this, then it is showing the value of revenue, which is my y, is 6115. So this is my predicted value for x1, x2 and x3. If I made second prediction, if I take model.predict here, if I write transportation cost as 10,000 and stationery cost as 9,000 and my packaging cost as 50,000, we can write any value here to predict. If I run this, it is showing the result of revenue is 36567. Means that's how you can predict the revenue based on different values of x1, x2 and x3. So these are simple 4 steps to build and predict the value using multiple linear regression model. Now, if we want to check the accuracy or score of our model, then we can use this syntax model.score x and y. Model.score. Here also we have to put x in the form of a 2D array. So I will copy this only. This is my x and this is my y, and paste here. This is my x, which contains 3 variables: transportation, stationery and packaging, and this is my y, which contains 1 variable, which is revenue. If I run this, then it is showing the accuracy of the model as 90%. 0.090 means there is an accuracy of 90%, which is good. We can also check the coefficients m1, m2 and m3 of our model. To check the coefficient, we have to simply use model dot coef underscore. So these are the coefficients m1, m2 and m3. You can learn about theory of multiple linear regression from Google. I am showing the practical example here. We can also check the intercept. To check the intercept, we have to use model. Model means this linear regression object. We can write any name here. You can write your name, you can write Python, you can write ABC, you can write city name, anything here. I have chosen model here. So we have to write our linear regression object name model dot intercept. So the value of intercept is 5412.81. This is our B. Now, as I told you that this is the equation of multiple linear regression. Y equal to m1 x1 m2 x2 plus m3 x3 plus b. If we try to predict the value of y by putting our values in this equation, then let's see the results. If we put m1, m1 is our this value. I copy paste here, multiply by x1. If I take x1 as 4200, second one is m2. m2 is my this value. Multiply by x2. x2 that I have chosen 1000 here. Plus m3. m3 is my this value, means third coefficient. Multiply by x3. x3 means the value of packaging that I have chosen 2500. Plus in the last we have to write the value of b. b is our intercept and the value of our intercept is this 5412 on this. Now I have put all the values in this equation. Now if I run this and if I print the value of y, then you can see it is showing the value as 6115.56, which is this value that I have predicted using the predict function. Here also I have using 4200,000 and 2500, and here also I have used 4200,000 and 2500. So this is how we can use multiple linear regression model and predict our outcomes. Logistic regression model. A logistic regression model is used to solve the classification problems. Here the predicted value or predictive variable, which is denoted by y, is a categorical or in discrete form. There are two types of classification: binary classification and multi-class classification. In binary classification, the outcome is in the form of yes or no, or you can say in the form of true or false. While in multi-class classification, it has multiple categories for outcome. In the binary classification, the outcome is either 0 or 1. If the value is between 0 and 0.5, then the output will be 0. But if the value is between 0.5 and 1, then the output will be 1. When we talk about logistic regression, then here we have a term sigmoid. Sigmoid is a mathematical function having a characteristic S-shaped curve or sigmoid curve. This curve exists between 0 and 1. It is especially used for models where we have to predict the probability as an output, because the probability exists between 0 and 1. If you see this figure, then it is a sigmoid curve. Its value exists between 0, which is present at the bottom side, and 1, which is present at the upper side. So this is the S-shaped curve, which is known as sigmoid. Here our aim is we have to create a model which will predict whether a person will buy the insurance or not. After creating this model, if the output comes 0, means when the probability is less than 50%, then we can say that the person will not buy the insurance. But if the output comes 1, means the probability will be greater than 50%, then we can say that the person will buy the insurance. So let's see the steps to create this simple logistic regression model. Here, first of all, we have to import the necessary libraries which will be required to create this model. We have to import Pandas, Numpy and Matplotlib. So this is the syntax to import these libraries. If I run this, the libraries are successfully imported. The next step is importing the dataset on which we will work and build our model. I have considered a very small dataset here for your better understanding and just for the explanation purpose. In the real world scenario, you will get a large dataset on which you have to work and get the output. So I am importing the dataset. My dataset is in Excel file and I am using this syntax pd.read_excel to import my dataset here. I will run this and my dataset has been imported in this Jupyter notebook. To have a look at my dataset, I will use the head function. So this is my dataset. Here are two variables. First is age and second is by. In this column age, we have age of the different persons, and in the column by we have 0, 1 values. In this column 0 means no, while 1 means yes. If the person didn't buy the insurance, then it is represented by 0 here. But if any person has bought the insurance, then it is represented by 1 here. Now we will draw a scatter plot to see the distribution of these data points. To draw the scatter plot, we will use the Matplotlib library that we have imported earlier. In this scatter plot, on x-axis we will plot our age, and on the y-axis we will plot the by column. I am giving the color red and I am setting the marker as star. If I run this, then this is the scatter plot. We can give label to x and y axis also. plt dot x label. On x axis we have our A's, while on the y axis we have our by, means yes or no. So this is the distribution of these data points. It is clearly showing that if the age is between 0 to 50, then the person didn't buy the insurance, while if the age is between or greater than 50 and less than 100, then the person has bought the insurance. These are the 0 and these are the 1s. And if I draw a S curve here, then we can simply draw from here like this and it will end here. The next step is training the model or building the model. To build the model, we will use the sklearn library here. First of all, from sklearn library, we will import the logistic regression model. And the syntax is this. This is the syntax to import the logistic regression from sklearn library. Next is creating a logistic regression object. We have to create a logistic regression object like this. It will create a logistic regression object. Next is fitting the dataset. We have to fit our data, means x and y, in this model. So we will use the fit function here. First we have to fit our x variable, which is our age, and it will be in the form of 2D array, means we have to give 2 square brackets here. After this we have to fit our y here like this. So if I run this, our model has been successfully trained or built. Now we can start making prediction using this model. First of all, we will predict whether a person of age 73 years will buy the insurance or not. To predict, we will use the predict function like this. We have to use our logistic regression object I have created here in the name of model. So I am using this here, and after this I am using the predict function. In the predict function, we have to put our age in the form of 2D array. So we are predicting for the age of 73. If I run this, then it is showing 1, means that the person will buy the insurance. If I predict whether a person with the age of 13 years will buy the insurance or not, then we will see model dot predict, and again here we will write our 2D array format and pass our age, for which we have to do the prediction. If I run this, then it is showing that the person will not buy the insurance. However, it is not guaranteed here that the person will not buy the insurance, but most probably we can say that he will not buy. Here also it is not guaranteed that the person will buy the insurance, but most probably he will buy the insurance if the person age is 73. So now to check the accuracy of our model, we can use the score function. Model dot score. In the score function, we will put our x and y. Again we have to put our x in the form of 2D array. Then we will put our y. If I run this, then it will show the accuracy of our model. It is showing 0.84, means our model is 84% accurate, which is good enough. The accuracy of our model could be better if we have a large data set and we have more accurate findings. If we again review this model, what we have done, first of all we have import our necessary libraries, then we have imported our dataset. Our dataset contains two columns, age and by. In age column we have the age of different persons, while in by column we have shown that whether a person bought the insurance or not. 0 means the person didn't buy an insurance, while 1 means the person has bought an insurance. Next, we have used the scatter plot to see the distribution of these data points. Here it is showing that if the age of the person is less than 50, then the person didn't bought an insurance, while if the age is greater than 50, then the person bought an insurance. Next, we have trained our model from sklearn library. We imported the logistic regression. Then we created a logistic regression object and fit our x and y in the model like this. In the next step, we have make the predictions using the predict function. For 73 years, it is showing that the person most probably will buy the insurance, while for the age of 13, it is showing that most probably the person will not buy the insurance. And in the last step, we have calculated our score or accuracy of the model. In our next video, we will create a simple decision tree model. After that, support vector machine model, then random forest model and KNN model. If you want to learn data analysis or big data analysis, then you can consider our these nodes where we have used Python, the core Python commands like this, many core Python commands. Also, we have the Numpy nodes to learn the Numpy library, and most important, we have the Pandas library nodes. Okay, so there are many functions that you can learn and enhance your skills. Also, we have Matplotlib library commands or nodes to create the different charts and plots, sine wave plot, multiple lines on a one graph, many different functions. And we have the join merge concat that we used in our last question number 13. Merge here, different formats, how to use. Then we have our SQL commands also to learn the SQL, many different commands, create table using another table, note between text function commands, then SQL joins. Okay, so that's all for this video. Thank you. For the notes, you can mail at the given email ID given in the description of this video. Also